Wish you all a very good day, my dear children. Now today we are going to discuss the first lesson in the grade 7 syllabus, that is bilateral symmetry. Now before we discuss this lesson in detail, let's discuss what this word bilateral symmetry means. Bilateral. We can break up this word into parts and analyze what it means. What is bi? Bi means two. Bi is two. Now you all know there is a small vehicle which has two wheels. Bicycle. Bi means two. Cycle means wheel. Thereby we can understand that bi is two. Then what is lateral? Lateral is side. Lateral means side. Now how do you call this figure? This is called quadrilateral. Quadra means four. Quadruped, having four legs like that. Quadra means four. Lateral is side. Four sides. Quadrilateral. Thereby we can understand that lateral is side. What is symmetry? What do you mean by symmetry? Having similar measurements or equal measurements. So that when we take the whole thing together, what is the meaning? Bilateral symmetry. Having equal measurements, similar measurements on two sides. On two sides. Sides from where? That is the next question. Alright. Now let's see what it is like. Now this is a certain sort of triangle. This is a special type of triangle. This side and this side both are equal. Anyway, now if we fold it like this, these measurements are different. But if we fold it along this line, here you are, the two halves coincide about each other, coincide with each other. None of these parts jut out. They very nicely coincide with each other, the two halves. Therefore, now we can understand from this line, all these measurements on either side are equal. Therefore, now you can fold this figure along this line to such that the two halves coincide with each other. Therefore, this line is called axis of symmetry. Axis of symmetry. From this axis, from this line, all these measurements are equal on both sides. Therefore, we can say that this is a figure which has bilateral symmetry. Now, we can take a paper like this. Take a paper like this and fold it in two. Fold like this and tear it in any shape like this. Then you can understand that when we unfold it once again, here you are. Now this is the fold line. Here I drew this fold line. This is the fold line. Here you are. Now from this fold line, all these measurements on either side are equal. Therefore, we can call this an axis of bilateral symmetry. But if you fold it in the other way like this, will they all be equal? No. This side short, this side long. So it has only this axis. You can't fold it along two lines to get two equal halves that coincide with each other. Right. Now, you can understand what axis of symmetry means. That means if there is a line along which you can fold this figure such that the two halves coincide with each other. Don't think that getting two equal halves is this thing. In certain cases, we can get two equal halves, but they don't coincide with each other. I will show you an example. Here you are. This is a rectangle. If you fold it like this half and this half, they are equal. But when you fold, even though they are equal, they don't coincide with each other. Therefore, this is not an axis of symmetry. Therefore, this is not an axis of symmetry. So, just because now it can be cut into two equal halves, it is not an axis of symmetry. Now, you must be able to fold the figure along that line such that the two halves coincide with each other. If that happens like that, we can call it an axis of bilateral symmetry. Okay. Now, I will show you a few figures which has bilateral symmetry. Bilaterally symmetric figures. Here you are. This is a triangle of which two sides are equal. Then you can fold it along this line. This is a bilaterally symmetric figure. This is the axis of symmetry. This is another one. Here you are. You can fold it like this along this line. But along this line you can't. You can fold, but the two halves do not coincide with each other. Therefore, this is not an axis of bilateral symmetry. But this one is an axis of bilateral symmetry. Right? This figure has an axis of bilateral symmetry. Okay. This is another figure, like a butterfly, which can be folded along this green color line such that the two halves coincide with each other. So, this is another, on this axis, this green color line, is the axis of bilateral symmetry. In here, this is a bit different from those ones. Why? Here you are, you can fold like this, then the two halves coincide. And even like this you can fold. Then also the two halves coincide. That means this line as well as this line. Both of these lines are axes of bilateral symmetry. You can fold it like this, then the two halves coincide. Fold like this, then also the two halves coincide. Both are two axes of symmetry. This one, here you are. The two halves coincide. On the other side, then also the two halves coincide. This also another figure which has two axes of bilateral symmetry. This is another one. But at once, at a glance, we can't decide whether it has bilateral symmetry. We have to check. Probably by folding like this, we can check whether it has bilateral symmetry. Now, when we fold, we can understand, we can see that this is an axis of bilateral symmetry because two halves coincide, nicely coincide. And along the other line, that also is another axis of symmetry. So, this also is another figure which has two axes of bilateral symmetry. What about this one? If you cut it like this, you can get two equal halves. But will they coincide when you fold? No. They don't coincide with each other when you fold. Therefore, this is a figure which hasn't bilateral symmetry. This one hasn't bilateral symmetry. Likewise, this one. If you fold like this, no. But none of these lines, by folding along none of these lines, you can get two halves that coincide with each other. Therefore, this is another figure which does not have bilateral symmetry. And this is another triangle. Now, earlier we discussed one triangle of which two sides were equal in length. But this one is not that. The three sides are different. there is no line along which you can fold to coincide the two halves. Therefore, this is another figure which does not have bilateral symmetry. This is another one. When you see it, sometimes you may feel as if it has bilateral symmetry. You may feel, because there are certain properties like that. Now it looks like that. Anyway, let's fold and see. Here you are. No, we can't get that line. This one? No, we can't get that line. Diagonal? No. No. So finally, we can understand that even though it looks like that, this is another figure which hasn't bilateral symmetry. In our surroundings also at times. Now when you take a leaf of a plant, it looks as if it has bilateral symmetry. There might be small differences. But butterfly is not there. It has bilateral symmetry. Now, it must have, otherwise it can't maintain its balance and fly. If one side is bigger, that side will go down. Therefore, butterfly is a creature which has bilateral symmetry. Alright, now we know what kind of figures, and now you know what is bilateral symmetry. What is bilateral symmetry? The property of having a line along which you can fold the figure such that the two halves coincide with each other. Right. Now let's discuss a few special figures. Some special figures. This is an equilateral triangle. Do you know what equilateral triangle means? All the three sides are equal in length. Here you are. You can fold it like this. You can fold it along this line, and you can fold it along this line. In all the three instances, the two halves coincide. Therefore, this is a special figure which has three axes of bilateral symmetry. Three axes of bilateral symmetry. What's this? This is an equilateral triangle. Then, let me take a square. What is a square? All the four angles are right angles and all the four sides are equal in length. Here you are. This is now, along this line you can fold like that to coincide. Therefore, this is an axis of bilateral symmetry. This one, that is another axis of bilateral symmetry. Diagonal, this one, that also is an axis of bilateral symmetry, and so is this one. So how many axes of bilateral symmetry has a square has got? There are four. There are also, now this is a figure which has three equal sides and all the angles also are equal. It has three axes. This is a figure which has four sides, but not an ordinary figure. Four sides, all the sides are equal in length, all the angles are equal. That is a square. It has four axes of symmetry. This is the most wonderful figure. What is this? This is a circle. This is the circle. Here you are. You can fold it like this, like this, like this, like this. Along any line that passes through the center, you can fold a circle to get two equal halves to such that the two halves coincide with each other. Therefore, unlike other figures, circle is very special. You can't say the number of axes of bilateral symmetry. Uncountable. Any line that passes through the center is an axis of bilateral symmetry. So, it is a very special property of the circle. Uncountable number of axes of symmetry. Alright, now let's discuss how to cut. How to cut a uh, figure, bilaterally symmetric figure. So how to create? Here you are, take a paper like this. Take this paper and fold. Earlier we did this. Then you can cut like this. Thereby you can get a figure, by unfolding, you can get a figure of which the two halves are equal. Two halves are equal. And if you fold it once again, like this, such that this angle is a right angle, then if you cut a figure, what will happen? Here you are. Let's unfold. You can fold along this line. And you can fold along this line also. So if you fold it twice, then you get a figure, twice and cut it like this, then you get a figure which has two axes of bilateral symmetry. Alright, that is quite enough for that. Now we are going to discuss another very important thing. Another very important thing. Here you are. On a square ruled paper, half of a figure has been given along with the axis of symmetry. A vertical line. Along with the axis of symmetry, half of a figure has been given. And you will be asked to create the other half of this figure. As it has been drawn on a square ruled paper, it's easy. How can you draw it? You count the number of squares. Here you are. From here, one square. Then on the other side, one square. On the other side, one square. One square, one square. From here, 1, 2, 3, 4. Then count the same number of squares. 1, 2, 3, 4. Mark it in here. Again, 1, 2. Then to this side, 1, 2. This one, 1, 2. To this side, 1, 2. This one, 1, 2, 3, 4. 1, 2, 3, 4. Alright. Now we have marked all the necessary points. Now we can join them. Like this. Take a foot rule anyway. Here you are. By counting the number of squares on either side, by taking similar number of squares on either side, you can get a figure. You can create a figure which has bilateral symmetry, which is bilaterally symmetric. Here, this is another one. Now, what's the difference between these two? What's the difference? The axis of symmetry is vertical, while this one has a horizontal axis of symmetry. On this also, you do the same thing. You just count from here one, from a square, from here to the other side one square. This one, 1, 2, 3, 1, 2, 3. Then 1, 2, here 1, 2, 3, 1, 2, 3. This one 1, 1. This one 1, 2, 3, 1, 2, 3. Then this one 1, 1. Now you can join them. Here you are, like this. So this is the method of creating a bilaterally symmetric figure on a square root paper. Right. This is all what you have to learn. Anyway, I would like to tell you another one very nice thing. Very funny, in fact. Now in my classes, once I asked my children, I gave this thing. half of a figure along with the axis of symmetry. Then I said that I asked them to, this is the axis of symmetry, other half of the face. Now do you know what they did? Now I asked them to draw the other half of the bilaterally symmetric figure. Instead, they drew the other half of the face. Mouth, chin and or the cheeks. Or these are the things that they drew. But what I asked was to draw the other half of the bilaterally symmetric figure. But this is not given on a square root paper. Can you suggest a suitable method for drawing the other half? Now, my dear children, you can take a carbon paper. But I don't have a carbon paper here, therefore, I took a small piece of white paper and rubbed a color pencil on that and made a paper like this. Now I can place this on the, place this like this. And on this one, I place this figure. And then I take a pen and firmly draw the figure, drive the pen along these lines firmly. And when you take it now, on the other side, slightly it has been marked. Now you can take the marker and draw this half. Thereby you can draw. Be careful that it is not the other half of the face. It is the other half of the bilaterally symmetric figure. Alright, that's all that we have to discuss for grade 7. Alright, now that's all what you have to learn in this lesson for grade 7. So, let's meet in another video. Wish you a very good day.